Somewhere out there tonight, on a green and living world beneath an ordinary sun, there is a layer of rock no thicker than your finger, and pressed into that thin dark line is everything that remains of a great civilization, one that rose and built and dreamed and died 80 million years ago. No cities are left, no monuments, no names, just a smudge in the stone that no one will ever read. Now here is the thought that should keep you awake. That is not a rare fate. That is what happens to almost everyone, and it may be the reason our sky is so silent, not because no one was ever there, but because the graves have no headstones. Get comfortable and settle in. A quick like and subscribe helps this channel reach more curious minds like you, because by the end of this, the silence overhead is going to sound less like an empty room and more like a cemetery. Now, let's gently drift into this. Lie back for a moment and picture the night sky the way you have always known it. The stars are steady and patient, scattered across the dark in the same arrangements that human beings have fallen asleep beneath for as long as there have been human beings. There is a particular comfort in that stillness. The sky asks nothing of you. It simply hangs there, quiet and enormous, and the quiet feels like emptiness. It feels like proof that we are alone, that the universe is a great dark room with almost nothing in it, and that we happen to be the small warm light burning in one corner. That is the intuitive reading of the silence, and tonight I want to sit with you and slowly take it apart. The question at the centre of everything we are going to talk about was asked over lunch, of all places. In the summer of 1950, at the laboratory in Los Alamos, the physicist Enrico Fermi was walking to the dining hall with a few colleagues, and the conversation had turned, as it sometimes did, to the possibility of other civilizations among the stars. They sat down, they kept talking, and then Fermi said the thing that has never stopped ringing in the ears of everyone who thinks about this. He asked simply, "Where is everybody?" It was almost a joke, but underneath it was a genuine puzzle, and the more you look at that puzzle, the less it feels like a joke, and the more it feels like a warning we have not yet learned to read. Consider the numbers, because the numbers are what give the question its weight. Our galaxy, the Milky Way, contains somewhere between 100 billion and 400 billion stars. The observable universe holds on the order of 2 trillion galaxies, each one its own island of hundreds of billions of suns, and all of this is old. The galaxy has been turning for more than 13 billion years, which is more than enough time for a single determined civilization to have spread from one end of it to the other, not once but many times over. If life is anything but a miracle, the galaxy should be busy. It should be crowded. It should be loud. And instead, after decades of pointing our most sensitive instruments at the sky and listening with everything we have heard nothing. No messages, no engines, no unmistakable sign that anyone has ever passed this way. Most people, when they meet this problem, reach for one of a small handful of answers. Maybe life is just extraordinarily rare, and we really are close to alone. Maybe there are others out there, but they are hiding, or too far away, or simply not interested in us. Maybe we are early, one of the first to arrive at the party before the other guests. These are reasonable answers, and we will touch some of them tonight. But there is another answer, darker and stranger, that we are going to spend the next couple of hours exploring together. It is the possibility that the silence is not the silence of an empty room at all. It is the possibility that the room is full, and that the reason it is quiet is that almost everyone in it is dead. I want you to hold on to that image, because it is going to be our companion through everything that follows. The universe is a graveyard. Say it once, and it sounds like a line from a poem, something dramatic and not quite meant to be taken literally. But by the time we reach the end of this countdown, I want that phrase to have earned a much heavier meaning. I want you to feel the difference between the silence of a place where no one ever lived and the silence of a place where a great many things lived and struggled and ended. Those two silences sound exactly the same from a distance. Telling them apart is one of the hardest problems in all of science, and it is the problem at the heart of this video. There is a reason a graveyard can be so hard to recognize, and it is worth planting the seed of it now, right at the beginning, before we have any of the theories in hand. The reason is that graves do not always come with headstones. Time is patient and enormous, and given enough of it, almost every trace of almost everything is worn away, buried, recycled, and forgotten. A civilization can rise and fall and vanish so completely that the world it lived on carries no obvious memory of it at all. Keep that thought in your pocket. We will take it out again much later, and when we do, it will change the way you hear the silence. Before we go any further, it is worth being honest about just how strange the silence really is, because the strangeness is easy to underestimate. When people first hear Fermi's question, a common reaction is to say that space is simply too big, that of course we have not heard anyone because the distances are so enormous, and we have been listening for such a short time, and there is truth in that. But it does not actually dissolve the puzzle, and here is why. The galaxy is not only large, it is also very, very old, and age is what turns distance from an excuse into a problem. Give a single expanding civilization even slow, ordinary means of travel, nothing faster than light, nothing exotic, just patience and self-sufficient ships, and the mathematics say it could spread from one end of the galaxy to the other in a few tens of millions of years. That sounds like a long time, and by human standards it is. But against the age of the galaxy it is almost nothing, a small fraction of 1% of the time available, which means that if even one civilization had ever arisen with the will to expand, at any point in the deep past, it could have filled the entire galaxy many times over before we were ever born. The galaxy has had time for this to happen not once but repeatedly, and yet, everywhere we look, we find no sign that it ever did. That is the real shape of the puzzle. It is not that we have not had time to hear anyone. It is that everyone else has had more than enough time to reach us, and no one has. So the silence is not the easy, expected quiet of a universe we simply have not finished exploring. It is a genuine and specific absence, a hole where something should be, and it demands a genuine and specific explanation. This is why the graveyard reading is worth taking seriously rather than dismissing. It is one of the few kinds of answer that can actually account for the strangeness, because it does not require that no one was ever there. It only requires that whoever was there did not last, or did not last in a form we can still detect. And that turns our attention, immediately and unavoidably, to the question of lifetimes, to how long a civilization endures once it begins. To organize our thinking, it helps to remember one particular piece of the puzzle that a radio astronomer named Frank Drake wrote down in 1961. Drake was trying to estimate how many civilizations in our galaxy might be broadcasting right now, and he built a kind of chain of factors to multiply together, one after another. How many stars form, how many have planets, how many of those planets host life, how many living worlds produce intelligence, and so on. But the very last factor in his chain is the one that matters most for us tonight. It is a single letter, L, and it stands for the average length of time that a communicating civilization actually lasts before it falls silent. And here is the quiet devastation hidden in that letter. You can be as generous as you like with every other factor in the chain. You can fill the galaxy with living worlds and thriving minds, and still, if L is small, if civilizations tend to be brief, then the number that are talking at this exact moment can collapse toward almost nothing. A galaxy that has produced millions of civilizations across its history can be silent tonight, simply because they did not overlap. That is the doorway we are about to walk through. Every one of the 10 theories in this countdown is, in the end, a story about L. Each one is a different answer to the question of what makes civilizations end, and each one, if it is true, helps explain why the sky above you is so quiet. Some of these deaths come from the stars themselves. Some come from the chemistry of life. Some come from the very technologies that make a civilization powerful. Some come from other civilizations. And one of them, the strangest of all, is not really about death, but about forgetting, about a graveyard so thoroughly erased that we could be standing in the middle of it and never know. We are going to count down from number 10 to number 1, and as we go, the fear is going to change. It is going to start as a distant, abstract thing, something happening to strangers among far-off stars, and it is going to end very gently much closer to home. So settle in, keep that quiet sky in your mind, and let us begin at number 10, with the softest of all the answers, the one that kills no one and yet leaves us alone anyway. Let us begin somewhere gentle, because the first theory in our countdown is not really about death at all. It is about timing. It is the possibility that the galaxy has been full of life and full of minds over and over again, and that we have simply never coincided with any of them. Not because they were destroyed, and not because they are hiding, but because the universe is so old, and each civilization is by comparison so brief that two of them lighting up close enough together to notice each other is a coincidence that almost never happens. This is the theory of the short window, and it is the softest crack in the comfortable idea that a silent sky means an empty one. To feel the force of it, you have to sit with the sheer amount of time involved. The galaxy is more than 13 billion years old. Write that number out and let it sprawl. Now compare it to the entire span of human civilization, from the first cities to this very moment, which is something like 10,000 years, and compare it to the part of our history in which we have been able to send signals to the stars at all, which is barely 100 years. Against the age of the galaxy, the whole radio history of humanity is not even a blink. It is a single spark thrown off a fire, bright for an instant and then gone. Now imagine that spark repeated across the galaxy, again and again, through all those billions of years. Imagine that civilizations arise fairly often, but that each one shines, in a way we could detect, for only a few thousand years before it changes, or quiets, or ends. Picture them scattered not just across space but across deep time, like matches struck in an enormous dark hall over the course of a very long night. One flares near the beginning and is gone before the next one lights far across the room. Another burns for a while in the middle of the hall, unseen by anyone, and goes dark long before we arrive. When you finally strike your own match and look around, the hall seems empty. But it is not empty. It is simply that almost no two matches were ever lit at the same moment, in the same place, close enough to see one another's light. It helps to shrink the numbers down to a size a human mind can actually hold, so let me try a trick with the calendar. Imagine compressing the entire 13 billion year history of the galaxy into a single year, from the 1st of January to the 31st of December. On that scale, each month stands for a bit more than a billion years, each day for something like 35 million years, and each second for a little over 400 years. Now place a civilization on that calendar. Suppose it broadcasts in a way we could detect for 1,000 years, which by the standards of these theories would be a fairly long and successful run. On our compressed calendar, 1,000 years is barely 2 seconds. So picture the whole year going by, January through December, and scattered across it here and there, a handful of civilizations each flickering on for about 2 seconds and then going dark. The chance that any two of those 2-second flickers happen at the same moment, in the same region of the sky, close enough to notice each other, is almost nothing. You could run that year again and again, and almost never catch two of them overlapping. That is the timing problem, drawn to human scale. We are not necessarily rare. We may simply be badly synchronized with everyone else, and the synchronization problem is even worse than it first appears, because it is not only about whether two civilizations exist at the same time, but whether they exist at the same time and close enough in space for their signals to reach each other before either one falls silent. Light is fast, but the galaxy is enormous, and a signal can take tens of thousands of years to cross from one side of our stellar neighborhood to the other. So even two civilizations that happen to overlap in time might miss each other completely, if the message from one took so long to arrive that the other had already gone quiet by the time it got there. You could be sending, and they could be sending, and the two of you could pass in the dark like ships whose lights went out just before they came within sight of one another. The window is not just short, it is short in 2 dimensions at once, in time and in space, and both of them have to line up for contact to be possible. This is what people sometimes call the problem of temporal dispersion, and it is worth saying plainly what it does to our search. When we point our instruments at the sky and listen, we are not listening to the whole history of the galaxy. We are listening to a single instant, the thin slice of time in which we happen to be alive and paying attention. A civilization that flourished 1 million years ago and then fell silent would be completely invisible to us. And 1 million years, remember, is nothing here. It is a rounding error against the age of the galaxy. So the sky could be littered with the remains of 1,000 civilizations, each of which lived and died in its own era, and our snapshot would catch none of them. We would hear silence, and we would mistake that silence for absence. The theory of the short window does not tell us why the windows are short. That question is the whole rest of the countdown, and every theory after this one is a different answer to it. This first theory only insists on the consequence. If communicating civilizations tend to be brief, for whatever reason, then loneliness is the default state of the universe, even in a cosmos teeming with life. You would not be alone in space. You would be alone in time, which is a stranger and sadder kind of solitude. You would be surrounded in every direction, by the ashes of the ones who came before you, and by the unlit kindling of the ones who have not yet begun. And you would never meet any of them, because the one thing you do not share is the present moment. There is something almost unbearably poignant in this when you turn it toward ourselves. Our own window opened only about 100 years ago, when we first began throwing radio waves out past the top of the atmosphere. That means our detectable signature, the shell of our broadcasts expanding outward into the dark, is only about 100 light-years thick. It is a thin bubble around a single star, growing at the speed of light, but still tiny against the size of the galaxy, and there is no guarantee that our window stays open. Already our most powerful broadcasts are changing, growing quieter and more efficient, leaking less into space. It is entirely possible that a curious neighbour, listening patiently from a nearby star, would catch only the faint edges of our brief noise, a soft rise and fall lasting a century or two, and then nothing, on either side, forever. Hold that thought against the quiet sky. The short window says the silence may not mean that no one is there. It may mean that everyone is scattered too thinly through time to ever share a night with us. It is the gentlest theory in our countdown, and it draws no blood. But notice what it has already done. It has cracked the comfortable assumption. It has made room for a galaxy that is full and silent at the same time, and it has left one enormous question hanging in the dark, the question that every remaining theory will try to answer in its own way. If the windows really are short, if civilizations really do burn briefly and then go out, then something is putting them out. So let us go looking for what that something might be. And let us start at number 9 with the suspect most people would never think to accuse, because the suspect is life itself. When we imagine what might destroy a civilization, our minds go outward, toward the sky. We picture asteroids, exploding stars, the cold indifference of space. But the 9th theory in our countdown asks us to look in exactly the opposite direction. It asks us to look inward, at life itself, and it suggests something deeply unsettling. It suggests that the greatest threat to life on any world may not be the hostile universe outside, but the living things on the planet's own surface. This is the Medea hypothesis, and to understand it, you first have to understand the beautiful idea it was built to oppose. For a long time, many people found comfort in a picture of life called the Gaia hypothesis, proposed by the scientist James Lovelock. Gaia is named after the ancient Earth Mother, and the picture is a warm one. In it, life and the planet form a kind of self-regulating whole, and living things tend, over the long run, to keep their world stable and habitable, adjusting the atmosphere and the climate to keep conditions comfortable for life to continue. It is the image of the planet as a nurturing mother, holding her children in a careful balance. It is a lovely idea, and there is some truth in it. But the paleontologist Peter Ward, who has spent his career reading the long record of life and death written in the rocks, looked at that same record and saw something very different. In 2009, he published a book proposing the opposite picture, and he gave it a darker name. He called it the Medea hypothesis, after a very different figure from Greek myth. Medea was not a nurturing mother. Medea was the mother who, in the old stories, killed her own children. And Ward's claim, drawn from the fossil record and the chemistry of ancient rock, is that life on Earth has behaved far more like Medea than like Gaia. His argument is blunt and disquieting. He looked at the great mass extinctions in Earth's history, the moments when a huge fraction of all living species were wiped away, and he found that nearly all of them were caused not by asteroids or by cosmic accidents, but by life itself. Living things, in his reading, repeatedly remake their own world in ways that end up being lethal to most of the life on it, including, very often, themselves. The clearest and most dramatic example is an event so old and so enormous that it reshaped the entire planet. Roughly 2.4 billion years ago, a new kind of life had learned a powerful trick. Certain bacteria had figured out how to harvest the energy of sunlight through photosynthesis, and as a waste product of that process they released a gas. That gas was oxygen. To us, oxygen means life. We breathe it without a thought. But to the world of that ancient time, a world whose living things had evolved in an environment with almost no free oxygen, that gas was a poison. As the photosynthetic bacteria multiplied and thrived, they pumped more and more of it into the oceans and the air, and it began to corrode and kill the older forms of life that could not tolerate it. This is sometimes called the Great Oxidation Event, and by some readings it was the largest extinction the planet has ever known, an act of mass killing carried out not by any disaster from space but by life, poisoning its own house through its own success. There is another example, later in Earth's history, that is even more directly murderous, and it is worth telling because it shows the pattern at its darkest. Around 250 million years ago, at the end of the Permian period, the Earth suffered the single worst extinction in its entire history, an event so severe that it is sometimes simply called the Great Dying. By some estimates, something like 90% of all species in the oceans were lost, along with the majority of life on land. It came the closest of any event we know of to ending complex life on this planet entirely. And while several forces seem to have combined to cause it, one of the suspects at the centre of the story is, once again, life itself. As the oceans lost their oxygen and stagnated, certain kinds of bacteria that thrive in oxygen-poor water appear to have flourished and spread, and those bacteria produce as a waste product hydrogen sulfide, a gas that is poisonous to most other living things. In the worst versions of this scenario, the poisoned oceans belched that gas into the atmosphere, killing life on the land as well, and even damaging the protective ozone layer high above. If that reading is right, then the closest the Earth has ever come to complete sterilization was not delivered by an asteroid or an exploding star. It was delivered by microbes, following their own chemistry, remaking the whole planet into something lethal. Ward points as well to the deep freezes, the episode sometimes called Snowball Earth, when the planet may have iced over almost from pole to pole. These too seem to have been driven, at least in part, by life altering the chemistry of the air, pulling so much carbon dioxide out of the atmosphere that the greenhouse warming which kept the world temperate collapsed, and the planet slid into a runaway cold. In each of these cases the specifics differ, but the shape of the story is the same. Life does something, succeeds at it, changes the chemistry of its world through that very success, and in doing so pushes the whole planet toward a state that is deadly to most of what lives on it. It is not malice. It is not even carelessness. It is simply what happens when living things, following their own nature, grow powerful enough to reshape the world that made them. Ward argues that this pattern repeats. Living things drive swings in the climate. They pull carbon out of the air or dump it back in. They flood the oceans with chemicals that, in the right concentration, become deadly. In several of Earth's worst extinctions, the killing agent seems to have been biology itself, in the form of runaway chemistry, poisonous gases like hydrogen sulfide bubbling up out of stagnant oceans, or the great planetary freezes sometimes called Snowball Earth, in which the whole world nearly iced over. And after each of these convulsions, the planet tends to fall back toward the same simple state it has spent most of its history in, a world dominated not by complex plants and animals but by microbes. Complex life in this picture is not the natural resting state of a living world. It is a rare, fragile, temporary flourishing, always at risk of being knocked back down by the very processes that life sets in motion. Now carry that idea off of Earth and out into the galaxy, because that is where it becomes a theory about dead civilizations. If Ward is right that biospheres tend to be self-destructive, then this is not a quirk of our particular planet. It is a general tendency of life anywhere. On world after world, life might take hold, flourish for a while, and then poison itself back down to simplicity, long before anything like intelligence ever has a chance to arise. The graveyard, in other words, may begin far earlier than we assumed. It may not be a graveyard of fallen civilizations at all, for most of its history. It may be a graveyard of whole biospheres, of living worlds that reach for complexity and were pulled back down by their own chemistry, again and again, across billions of years. There is a mirror here that is hard to look away from. When we worry, in our own time, about the way our activity is changing the chemistry of our atmosphere and the balance of our climate, we tend to think of ourselves as uniquely reckless, as if we were doing something no living thing had ever done. The Medea hypothesis says the opposite. It says that life has always been capable of this, that altering a planet's chemistry to the point of catastrophe is one of the oldest things living things do, and that we are only the latest to do it with a new set of tools. It reframes the danger. The threat is not that we are unnatural. The threat is that we are entirely natural, and that what feels like an accident may in fact be a deep and recurring habit of life itself. It is worth being fair to the other side of this argument, because the Medea hypothesis is not the final word, and the truth is probably more tangled than either Medea or Gaia alone. life has clearly done more than poison itself. It has also, over the long run, transformed this planet into the rich, layered, endlessly productive world we inhabit, building soils, seeding the air with the oxygen we now depend on, weaving the intricate webs of dependency that let complex creatures like us exist at all. The same oxygen that was a catastrophe for the ancient anaerobic world became, in time, the foundation of everything that breathes today. So life is not purely a destroyer any more than it is purely a nurturer. It is both, by turns, sometimes building and sometimes tearing down, and which face it shows seems to depend on the moment and the scale at which you look. What the Medea hypothesis adds is not a claim that life is only Medea, but a warning against the comfortable assumption that life only ever tends toward balance and stability. It insists that the destructive face is real, that it has shown itself again and again in the record of the rocks, and that we ignore it at our peril. And that warning is exactly what makes this theory belong in a countdown about dead civilizations, rather than in a textbook about ancient biology. Because if the destructive face of life is a general tendency, rather than an Earth-specific accident, then it becomes a filter that operates on living worlds everywhere, quietly, patiently, long before any of them could ever produce a radio signal for us to miss. Picture the galaxy seeded with living worlds, thousands upon thousands of them, each one a place where life took hold and began its long climb. Now imagine that on most of them, at some point in that climb, life does what the Medea hypothesis says it tends to do. It succeeds too well at something, tips the chemistry of its world, and collapses back towards simplicity, resetting the whole experiment to its microbial beginnings. On such worlds, the climb toward complexity might have to start over, and over, and over, each attempt knocked back down before it can reach the heights that intelligence requires. Some of those worlds might simply run out of time, their sun aging and swelling toward its own death before life ever manages to string together enough uninterrupted good fortune to build a mind. The graveyard on this reading would be full not of fallen cities but of fallen biospheres, of living worlds that reached upward again and again and were pulled back down each time by the very vitality that lifted them. There is one more thing worth saying here, because it connects this ancient story directly to our own moment in a way that is hard to ignore. When we look at our present situation, at a civilization rapidly changing the composition of its atmosphere and the balance of its climate, we tend to frame it as a uniquely modern crisis, a problem created by machines and industry, and the peculiar habits of one clever species. The Medea hypothesis offers a stranger and in some ways more humbling perspective. It suggests that what we are doing is not fundamentally new at all. Altering the chemistry of a planet to the point of danger is, in this view, one of the oldest and most recurrent things that life does. The cyanobacteria did it with oxygen, billions of years before anyone could regret it. Other organisms did it with methane, with sulfide, with carbon, in episode after episode across the depths of time. We are only the latest to arrive at that ancient threshold, and the first to be able to watch ourselves crossing it, and to understand, at least dimly, what we are doing. That understanding is the one genuinely new thing we bring, and it may be the only thing that lets our story end differently from all the others. So the ninth theory hands us our first suspect, and it is a strange one to accuse. The suspect is not the cold sky. The suspect is life, which builds itself up and then, so often, tears itself back down. It is a death that comes from within, from the planet's own thriving, and it can strike long before any civilization exists to be mourned. But of course, on our own world, life did not stop at microbes. It kept going, past the simple and into the complex, all the way up to minds and machines and radio signals thrown out at the stars. And once you have minds and machines, a whole new category of death becomes possible, one that does not need biology's slow chemistry at all. To find the next suspect, we have to leave the surface of the planet and look up at the most violent events the universe has ever produced. That is where we're going at number 8. We have found death in the timing of things and death in the chemistry of life. Now we lift our eyes off the planet entirely and look at the universe as a place that can reach down and kill, without warning, from unimaginable distances. The 8th theory in our countdown is about the most violent event known to science, an event so powerful that a single one of them can outshine everything else in the sky combined. It is about the gamma-ray burst, and about the growing suspicion among some scientists that these bursts have functioned, across the history of the galaxy, as a kind of periodic sterilizing sweep a scythe passing again and again through the fields of life. Let me try to give you a feeling for how much energy we're talking about, because the numbers alone slide off the mind. Our sun is a steady, generous star, and it will shine for something like 10 billion years, pouring out light the entire time. A gamma-ray burst can release, in a few seconds, more energy than the sun will produce across that whole 10 billion year lifetime, in seconds. And it does not spread that energy gently in all directions. It focuses it into narrow beams, like the sweep of a lighthouse, so that anything caught in the path of the beam receives the full, concentrated fury of it. These bursts are thought to come from the collapse of certain enormous stars and from the collision of the ultra-dense remnants of dead stars. For a few seconds, in a galaxy far away, a burst can briefly become the single brightest thing in the entire visible universe, and it happens without any warning at all. In 1999, an astrophysicist named James Annis put forward an idea that took these monstrous events and connected them directly to the silence of the sky. Annis suggested that gamma-ray bursts might act as a regulator on the appearance of complex life across the whole galaxy. In the distant past, when the universe was younger and denser and the bursts were more frequent, he proposed that they would have swept through the galaxy often enough to repeatedly wipe the slate clean, sterilizing the surfaces of countless worlds before life on them could ever climb very far. And then, as the universe aged and the rate of these bursts gradually declined, he imagined a kind of turning point, a moment when the galaxy became, for the first time, calm enough for complex life to persist long enough to get anywhere. He described it almost as a phase transition, a change of state, as if the galaxy had spent its early history too violent to hold life for long, and had only relatively recently settled into something survivable. If that idea is right, it carries a haunting implication. It would mean that we are not late to the party at all. It would mean that we might be among the first, not because life is rare, but because the universe spent most of its existence periodically killing everything that tried, and only recently stopped. The graveyard in this reading is enormous and ancient, filled with the remains of life that never had a chance because the sky kept catching fire. For a long time this was a compelling idea without hard numbers attached. Then, in 2014, two scientists named Svi Piran and Raul Jimenez published a careful study in the journal Physical Review Letters that put real probabilities on the danger, and the probabilities were sobering. They gathered what we know about how often gamma-ray bursts occur, how bright they are, and what kinds of galaxies they tend to happen in, and they calculated the odds that a burst close enough and aimed well enough to be lethal would have struck a planet like Earth. Their conclusion was that there is roughly a 50% chance that a lethal gamma-ray burst has swept over the Earth at some point in the last 500 million years, and when they stretched the window out to the last 5 billion years, roughly the age of our planet and our sun, the odds climbed to more than 90%. Over the lifetime of the Earth, in other words, it is more likely than not that we have already been hit. But the part of their study that matters most for our purposes is what they found about location. The danger from gamma-ray bursts is not spread evenly across the galaxy. It is far worse toward the centre. The inner regions of the Milky Way are crowded, dense with stars and with the kinds of environments that produce these bursts. Piran and Jimenez calculated that within a certain distance of the galactic centre, a region a few thousand parsecs across, the probability of a lethal burst rises above 95%. In effect, the busy star-rich heart of our galaxy may be a place where complex life simply cannot last, because it is scrubbed clean too often to ever build toward anything. The only reasonably safe neighbourhoods are the quieter outskirts, the thinner suburbs of the galaxy far from the crowded core, where the bursts come rarely enough that life has room to accumulate. There may be, in other words, a habitable zone not just around a single star but around the whole galaxy, a ring of relative safety with a killing field at its centre. The way a gamma-ray burst kills is worth understanding, because it is not what you might expect. A burst that reaches a planet does not necessarily scorch the surface directly. What it does is worse and quieter. The flood of gamma radiation slams into the upper atmosphere and tears apart the ordinary molecules there, converting nitrogen and oxygen into compounds like nitric oxide. Those compounds are devastating to the ozone layer, the thin shield of gas high above the surface that protects everything below from the sun's ultraviolet radiation. Within moments, a burst can strip away much of that shield, and it can keep it depleted for months or even years afterward, and with the shield gone, the ordinary sunlight of the planet's own star becomes lethal, pouring unfiltered ultraviolet down onto the surface, breaking apart the base of the food chain, killing the small organisms in the upper layers of the oceans on which so much else depends. The star that gave the world its life becomes the instrument of its death, once the burst has torn away the protection. It is worth dwelling on that idea of a galactic habitable zone, because it changes the way you should picture the whole galaxy as a place for life. We are used to thinking about the habitable zone around a single star, the band of orbits where a planet is neither too hot nor too cold for liquid water. But the gamma-ray burst research suggests that there may be a second, much larger habitable zone, drawn around the entire galaxy. The crowded central regions, rich in stars but also rich in the violent events that produce bursts, may be too dangerous for complex life to ever accumulate, scrubbed clean too often to build toward anything lasting. The thin outer edges, where stars grow sparse, may lack the ingredients life needs, and in between, in a ring at a comfortable distance from the deadly core, there may be a band where the danger is low enough and the resources high enough for life to have a real chance. If that picture is right, then most of the galaxy is not a garden at all. Most of it is either too violent or too barren, and only a modest ring of it is truly hospitable. The graveyard in this reading is not scattered evenly. It is concentrated toward the centre, where the killing was worst, and the survivors, if there are any, cling to the safer suburbs. And there is something almost vertiginous in realizing that our own position, far out in one of the galaxy's quieter spiral arms, well away from the dangerous core, may not be an accident at all. It may be a precondition. It may be that the only reason we're here to ask these questions is that our solar system happens to sit in one of the calmer neighborhoods, in the habitable ring rather than the killing field, where the burst came rarely enough that life had the billions of uninterrupted years it needed to climb all the way from single cells to creatures who look up and wonder. On this reading, the peacefulness of our particular corner of the sky is not a promise about the whole universe. It is a local privilege, a quiet street in a city with far more dangerous districts, and our sense that space is calm may simply reflect the fact that we grew up somewhere that was. There is even a candidate for a time this may have happened here, on our own planet. Around 440 million years ago, the Earth went through one of its great mass extinctions, the late Ordovician extinction, in which something like 85% of marine species were lost. Some scientists, including researchers named Adrian Mellott and Brian Thomas, have proposed that a nearby gamma-ray burst could have been at least part of the cause, stripping the ozone layer, flooding the shallow seas with ultraviolet light, and helping to trigger the global cooling that accompanied the die-off. It remains a hypothesis, not a proven fact. But it is enough to make the danger feel real rather than theoretical. It is enough to suggest that we may already carry, in our own fossil record, the scar of a wound delivered from across the galaxy. I want you to feel, for a moment, what such an event would actually be like, because its horror is precisely in how little there is to feel. Imagine standing on a world much like this one, a living world with oceans and weather and creatures going about their lives. Thousands of light years away, long ago, two dead stars have spiraled into each other, and in the instant of their collision they have flung out a beam of gamma radiation that has been crossing the dark ever since, thinning and spreading but still carrying more energy than a star pours out in its entire life. There is no telescope that sees it coming, because it travels at the speed of light, which means it arrives at the exact same moment as the first possible news of it. The sky does not darken in warning. There is no sound, no tremor, no sign. One ordinary afternoon the upper air simply begins to change, high above where anyone can see, and the invisible shield that has protected every living thing on the surface for 1 billion years begins to come apart. The flash and the death arrive together. By the time the world could know what had happened, the wound is already made. That phrase is worth holding on to because we will need it again before the end. The flash and the death arrive together. It is a fact about physics, about the way light and its consequences travel at the same speed, so that some dangers give no warning by their very nature. But it is also, as we will see, a fact about knowledge itself, about how a civilization can fail to recognize the thing that is killing it until it is already inside the event. For now, hold it as it stands, as a simple, brutal truth about the gamma-ray burst. The universe can reach across thousands of light years and end a living world in an afternoon, and the first sign of it is the ending. So the eighth theory shows us death coming from the outside, from the sky, indifferent and enormous. It shows us a galaxy that may have spent most of its history too violent to hold life, with a killing field at its centre and only a thin ring of safety at the edges. It fills the graveyard from above. But there is a kind of death stranger than this, one that does not come from the sky or from the slow chemistry of biology, but from the very thing that makes a civilization powerful in the first place. To find it, we have to come back down from the stars and think about what happens when a species learns to harvest energy and build, because it turns out that building itself, the act of becoming a civilization at all, may carry a trap inside it. That is number 7. The theories we have seen so far involve either bad luck or the slow habits of biology. The 7th theory is different, and in some ways more disturbing, because it does not rely on luck at all. It suggests that the thing which ends civilizations is not an accident that might be avoided, but a consequence of physics itself, built into what it means to be a civilization. It suggests that any species that grows powerful enough to reshape its world runs into the same wall, not because it is foolish, but because it is obeying the same laws of energy and heat that govern everything else in the universe. This is what we might call the thermodynamic trap, and it turns the story of the graveyard from one of misfortune into one of near inevitability. To understand it, we have to start with a very simple and very deep idea. Every time you do work, you generate waste. This is one of the most fundamental truths in all of physics, tied to the concept of entropy, the tendency of ordered energy to spread out and become disordered heat. When you use energy to accomplish something, to build, to move, to compute, to grow, you never get all of that energy back as useful work. Some of it always escapes as heat, spilling out into the surroundings. There is no way around this. It is not a matter of clever engineering. It is a rule of the universe, and what is true for a single machine is true, at enormous scale, for a whole civilization. A civilization is, from a certain point of view, a giant engine for turning energy into activity, and like any engine, it cannot run without producing waste heat and shedding it into its environment. The environment for a civilization is its planet. In 2018, the astrophysicist Adam Frank, working with the researchers Jonathan Carroll Nellenbach, Marina Alberti, and Axel Kleiden, published a study in the journal Astrobiology that took this idea seriously and tried to generalize it. Their title was telling. They called it the Anthropocene Generalized, borrowing the word we use for the current age of human influence on the Earth and asking what it would look like as a universal phenomenon. Their claim was that the situation we find ourselves in, a civilization growing large enough to alter the chemistry and climate of its own planet, is not a peculiarly human failing. It is a generic outcome. Any species anywhere that begins harvesting energy and building on a large scale will, by the same physics, begin to change its world, and those changes will feed back on the world's ability to support the civilization that caused them. Climate disruption, in this view, is not an Earth problem. It is a civilization problem, and it should be expected to appear on any world where a technological society arises. What makes their work more than a warning is that they built actual mathematical models of these coupled systems, treating the civilization and its planet as two things locked together, each affecting the other. A growing civilization consumes more energy, which alters the planet, which changes the conditions the civilization depends on, which in turn affects how the civilization can grow. Then they ran these models forward under a wide range of assumptions to see how the story tended to end, and the results were not comforting. Across most of the scenarios they explored, the trajectories led to some form of collapse. In many cases, the population would rise steeply, overshoot what the altered planet could support, and then fall sharply, a difficult and painful die-off. Only a narrow set of paths led to something sustainable, a stable, steady state in which the civilization and its planet settled into a lasting balance. And crucially, those good paths tended to require the civilization to change course early, to recognize the trap and adjust its relationship with energy before the feedback had run away with it. The worlds that waited too long did not get a second chance. It is worth pausing on why waste heat, of all things, is such an inescapable problem, because it is easy to assume that a sufficiently advanced civilization could simply engineer its way around it. Cleaner energy, better efficiency, smarter design, surely all of that would solve it. And up to a point, it helps. But the deepest version of the problem does not care where your energy comes from. Even if a civilization drew all of its power from a perfectly clean source, the mere act of using that power to do work, to run machines and cities and computers and everything else a civilization does, converts ordered energy into waste heat, which has to go somewhere. On a planet, there is only one place for it to ultimately go, which is out into space, radiated away as infrared. And a planet can only shed heat so fast. If a civilization keeps growing its energy use, doubling and doubling as ours has done for a long time, then sooner or later the sheer quantity of waste heat it produces begins to warm the planet all on its own, independent of any particular fuel or any particular pollutant, simply as a consequence of using that much energy in a confined space. This is a far-off limit for us, not our immediate concern, but it illustrates the point at its most fundamental. The trap is not any single technology. The trap is thermodynamics, and thermodynamics does not accept clever excuses. What the models of Frank and his colleagues suggest is that a civilization and its planet, taken together, tend to fall into one of a small number of long-term outcomes, like a ball rolling across a landscape and settling into one valley or another. In some of those valleys, the civilization overshoots and collapses hard, its population crashing after it has pushed its world too far. In others, it declines more gently to a lower, sustainable level after a painful die-off, and in a rare and narrow valley, it manages a soft landing, finding a stable balance with its planet that can last indefinitely. The disturbing finding is not that the good outcome is impossible. It is that the good outcome is the exception, reached only by trajectories that change course early and deliberately, while most paths, left to run on their own momentum, roll into one of the valleys of collapse. The universe does not forbid a sustainable civilization. It just makes it the hard, narrow, uncommon path. Sit with what that implies for the galaxy. If Frank and his colleagues are even roughly right, then the sustainability bottleneck is not a rare misfortune that strikes the unlucky few. It is a gate that stands in front of every technological civilization, everywhere, by the logic of thermodynamics itself, and the models suggest that most of the time the gate does not open. Most of the time, the civilization runs into the wall of its own waste and its own growth, and it collapses. The graveyard in this reading is not filled by asteroids or exploding stars. It is filled by success, by civilizations that did exactly what civilizations do, that grew and built and consumed, and that discovered too late that the act of building had quietly undermined the ground they were standing on. There is something almost tragic in the shape of this. The theories about gamma-ray bursts are, in a strange way, easier to bear because they involve an external enemy, a violence that comes from outside and that we did not cause. The thermodynamic trap is harder because there is no enemy in it at all. There is only physics, and a civilization doing what comes naturally, and a planet responding the way any planet must. It is death by ordinary law. It is what happens when you obey the rules, and that is exactly why it is so hard to escape, because you cannot outwit a law of nature by being clever. You can only respect it and change your behavior in time, which requires seeing the trap clearly while you're still inside the part of the story, where seeing it clearly can still make a difference. And of course this is the theory that is hardest to hold at arm's length, because we are living inside it right now. We are, at this very moment, a civilization that has grown large enough to change the chemistry of its own atmosphere and the balance of its own climate, generating waste on a planetary scale, watching the feedback begin to arrive. Frank has been explicit that this is the point. The reason to think about exo-civilizations and their planetary feedback is not idle curiosity about aliens. It is that the same physics applies to us, and that by imagining the general case, we might understand our particular case more clearly. We are one of the trajectories in the model, somewhere along the curve, and we do not yet know which curve we are on. We do not know whether we are on one of the rare paths that bends toward a stable, lasting balance, or one of the many that rise steeply and then break. The experiment is still running, and we are inside it, and there is no observer outside to tell us how it comes out. Notice, too, how quietly this kind of death would erase itself from the sky. A civilization killed by its own thermodynamic feedback does not go out in a flash that another star system might notice. It simply grows loud for a century or two, spilling its radio and its heat into space, and then it falls quiet as its world turns against it and its numbers collapse. From far away, all you would ever see is a brief brightening, and then a return to silence, indistinguishable from the short window we spoke about at the very beginning. The thermodynamic trap does not just fill the graveyard. It fills it in a way that leaves the sky looking exactly as empty as if no one had ever been there at all. So the seventh theory hands us a death written into the laws of physics, a wall that any civilization may hit simply by growing. But there is a subtler cousin to this idea, a different kind of trap that does not depend on climate or heat at all, but on something even more basic: the raw materials a civilization needs to become technological in the first place. It is the possibility that a world offers only one chance at this, one inheritance to be spent, and that a civilization which stumbles gets no second attempt. That is number 6. There is a kind of loss that is easy to overlook, because it does not look like death in the ordinary sense. The 6th theory in our countdown is about it. It is the possibility that a civilization can end, not as a species and not even as a living world, but as a dream, that it can lose forever its one and only chance to reach the stars and go on living for ages afterward without ever being able to try again. This is the theory of the one-shot window, and it depends on a quiet fact about how technological civilizations are built, a fact so obvious that we rarely stop to notice how fragile it makes us. Here is the fact. A technological civilization does not build itself out of nothing. It builds itself out of a specific inheritance, a store of concentrated resources that the planet spent hundreds of millions of years slowly preparing. Think about what our own rise to technology actually required. It required dense, burnable fuels, coal and oil and gas, which are the buried and compressed remains of ancient life, laid down over immense stretches of geological time. It required metals, gathered into ores rich enough and shallow enough to be dug out and worked. It required, in short, a planet that had been quietly stockpiling usable energy and usable materials for eons, so that when a curious species finally came along, the shelves were full and the tools were within reach. We did not notice how much this mattered, because to us it simply felt like the world being the way the world is. But it was an inheritance, and inheritances can be spent. Now, here is the trap. That inheritance is, for all practical purposes, a one-time gift. The easy, concentrated, near-surface resources that let a civilization climb from muscle power to machines can only be gathered once. When you burn the coal, the energy in it is gone, spread out as heat and scattered gas, and the planet will not make more on any timescale that matters to a civilization. When you dig out the rich, shallow ores, what remains is deeper, thinner, and harder to reach. The first climb up the ladder of technology is made using the lowest and easiest rungs, the resources you can get to with simple tools before you have any advanced machinery at all. And once those rungs are used up, they are not there for anyone who comes after. Follow that logic to its unsettling conclusion. Suppose a technological civilization arises on some world, climbs to something like our level or beyond, and then, for any of the reasons we have been discussing, collapses. Suppose its numbers crash, and its knowledge scatters, and it falls back to a simpler way of living. The species might survive, the biosphere might be entirely intact, life goes on. But the ladder that the first civilization climbed is now gone. The easy fuels have been burned, the shallow ores have been dug out and dispersed. A new civilization, rising from the wreckage of the old one thousands or millions of years later, would find itself on a world stripped of exactly the resources that made the first climb possible. It could not bootstrap heavy industry the way its predecessor did, because the raw materials for that first crucial push are no longer lying within reach. You cannot build the first engines out of diffuse, deep, low-grade leftovers. You need the concentrated inheritance, and the inheritance has already been spent. There is a concept that makes this trap sharper, an idea that engineers and energy analysts sometimes call the energy return on investment. The idea is simple. To get energy, you have to spend energy. You have to build the mine, dig the shaft, drill the well, refine the fuel, construct the machines. What matters is the ratio between the energy you get out and the energy you had to put in to get it. And the reason the first industrial climb was possible is that the early, easy resources had a spectacularly favourable ratio. Surface coal and shallow oil gave back enormous amounts of energy for very little effort, because a planet had spent hundreds of millions of years concentrating them into rich, accessible deposits. That extraordinary surplus, that huge return on a small investment, is what powered the whole ascent. It gave a civilization the spare energy to build everything else on top of it. Now imagine trying to make that first climb again, after the easy deposits are gone. The resources that remain are deeper, thinner, more scattered, and more stubborn. Their energy return is far worse. It takes much more effort to get much less back. And here is the cruel part. To reach those difficult low-return resources at all, you already need advanced technology, powerful machines, sophisticated industry, the very things you were trying to build in the first place. You need to be an advanced civilization in order to gather the resources that a rising civilization would need in order to become advanced. It is a ladder whose lowest rungs have been sawn off, leaving a gap at the bottom that cannot be crossed by anyone starting from below. The first civilization could climb because the easy rungs were there. A second one, starting again from the ground, would reach up and find nothing within grasp. If that is true, then a world may get exactly one attempt to become a spacefaring civilization. One, and if that single attempt fails, if the first technological civilization on a planet stumbles and falls before it manages to get established among the stars or to transition to some renewable footing, then the door may close permanently. The planet keeps its oceans and its forests and its living things, but it has lost, forever, its shot at the stars. It becomes what we might think of as a grounded world, a place still full of life, perhaps even full of intelligence, but incapable of ever again mounting the kind of technological ascent that could carry it off the planet or announce it to the galaxy. This reframes what we even mean by death in this countdown, and it is worth pausing on that. Every theory before this one has involved something ending, life poisoning itself, a burst sterilizing a surface, a civilization collapsing under its own weight. But the one-shot window describes a subtler ending, a death that a living world could suffer without any obvious catastrophe at all. The civilization does not necessarily go extinct. The planet does not become a wasteland. What dies is a possibility, the possibility of ever reaching outward, ever building the kind of lasting, expanding, communicating civilization that could break the silence. And a galaxy could be full of such worlds, green and alive and permanently silent, not because nothing lives there, but because whatever lives there already had its one chance and lost it. There is something quietly devastating about this when you turn it toward our own situation, because we are, right now, in the middle of spending our inheritance. Every ton of coal we have ever burned, every barrel of oil, every rich seam of metal we have dug out and used, is a rung we have taken off the bottom of the ladder behind us. We built our entire technological civilization by reaching down into that ancient store and pulling the energy up into the present, and we have been doing it so quickly and for such a short time that we rarely think about the fact that it cannot be redone. If our civilization were to fall now, in a way that scattered our knowledge and crashed our numbers, whoever came after us thousands of years from now would inherit a world from which the easy path to industry had already been removed. They would look at the same sky we look at, and they might dream the same dreams of the stars, and they might find those dreams simply unreachable, because we had already climbed the ladder and pulled it up. That is a heavy thought to sit with, and it changes the texture of the whole enterprise. It means that the window in which a civilization can become spacefaring is not only short in time, as the very first theory suggested. It may also be single, unrepeatable, a one-time opening that either you pass through or you do not. It raises the stakes of every stumble. A collapse is not just a tragedy to be recovered from over the generations. It may be the permanent closing of the only door the planet was ever going to offer, and the graveyard once again fills up in a way that leaves no obvious mark because a grounded world looks, from across the light years, exactly like a world where no civilization ever arose at all. So far, every death in our countdown has been, in a sense, impersonal. Bad timing, the chemistry of life, the violence of the sky, the laws of thermodynamics, the finite gift of a planet's resources. None of these theories has required a civilization to do anything actively self-destructive. But now we arrive at the part of the countdown where that changes, where the cause of death moves inside the civilization itself, into its choices and its conflicts and its own terrible cleverness. We are moving into the second half of our list, and the fear is going to become more personal from here, because the next suspect is the one that Carl Sagan feared most, and it is the one that points most directly, most uncomfortably at us. That is number 5. We have crossed into the second half of the countdown, and the character of the fear changes here. Until now, the deaths we have discussed have come from outside the will of the civilization, from timing, from chemistry, from the sky, from physics, from the finite gifts of a planet. But the fifth theory is about a death that a civilization does to itself, deliberately or carelessly, with its own hands and its own tools. It is the possibility that the very intelligence which lets a species build starships is the same intelligence that lets it build the means of its own destruction, and that these two capacities arrive at almost exactly the same moment, so that a civilization becomes able to end itself at precisely the point when it becomes able to be noticed. This is the theory Carl Sagan spent much of his life worrying about, and of all the theories in this countdown, it is the one that stares back at us most directly. Return for a moment to that single letter in Drake's chain of factors, the letter L, the average lifetime of a communicating civilization. We said at the beginning that this is the term that matters most, because a small L can silence a galaxy no matter how generous everything else is. The question the fifth theory asks is simple and terrible. What if the thing that makes L small is the civilization itself? What if most technological species, shortly after they gain the power to reshape their world, use some fraction of that power to destroy themselves, and do it so reliably that the typical lifetime of a broadcasting civilization is measured not in millions of years, not in tens of thousands, but in mere centuries? The logic behind this fear is uncomfortably sound. Consider what technological knowledge actually is. It is not a collection of separate, isolated tricks. It is a single deep understanding of how the world works, and that understanding is neutral. The same grasp of physics that lets you generate power from the atom lets you build a weapon from it. The same mastery of biology that lets you cure disease lets you engineer one. The same skill in building thinking machines that could carry a civilization to greatness could, if it slips out of control, produce something that pursues goals no one intended with a competence no one can match. Knowledge does not come divided into safe knowledge and dangerous knowledge. It comes whole, and every powerful capability carries its shadow. A civilization does not get to choose to have only the constructive half. It gets both, at once, whether it is ready or not. And here is the cruel timing at the center of it. The moment a civilization becomes visible across interstellar distances, the moment it starts throwing radio and other signals out into the dark, is essentially the same moment it becomes capable of destroying itself. These are not separated by long ages. They are the same technological threshold, reached at nearly the same time, because they draw on the same underlying knowledge. So a civilization switches on, becomes detectable, begins to shine into the galaxy, and in that very same window it acquires for the first time the ability to end its own story. If it survives that window, it might go on to last for ages, quiet and wise and enduring. But if it does not, then all the galaxy ever sees is a brief flare of signals, switching on, and then, a century or two later, switching off. Over and over, across billions of years, the sky fills with these short-lived sparks, each one a civilization that reached the threshold and did not make it through. Sagan called this, in his own words, a kind of technological adolescence, and the phrase is worth dwelling on. Adolescence is the dangerous passage between childhood and maturity, the time when a growing thing has acquired real power but has not yet acquired the wisdom or the steadiness to wield it safely. A civilization in its technological adolescence has the strength of an adult and the judgment of a child. It can remake continents and split atoms and rewrite the code of life, and it is doing all of this for the first time, without any experience of the consequences, without any older civilization to warn it, learning as it goes, with the stakes suddenly raised to the level of its own survival. The question is not whether intelligence can arise. We are proof that it can. The question Sagan kept returning to is whether intelligence can survive its own adolescence, whether a species can hold that much power in young hands long enough to grow into it. I want to slow down here, because this is one of the moments in our countdown where the distance between us and the theory closes entirely. Everything we have discussed so far you could hold at arm's length. Bad timing among far-off stars, the chemistry of alien biospheres, gamma-ray bursts in distant galaxies, even the thermodynamic trap in the one-shot window we could discuss as general principles. But this one is not distant, and it is not general. We are right now living inside the exact window this theory describes. We crossed the technological threshold within the last century or so. We learned to broadcast, and in almost the same breath we built weapons capable of ending our own civilization. We are, as I speak these words, roughly 80 years into our own nuclear age, which is to say we are somewhere in the earliest, most dangerous part of the passage, still very much an adolescent species, still holding more power than we have yet learned to handle. Think about what that means for how you should hear this particular theory. It is not a story about someone else. When we picture the long table of the galaxy with its rows of empty chairs, the chairs of all the civilizations that reached this stage and vanished, this theory is the one that says one of those chairs is still occupied, and it is ours, and we do not yet know whether we get to keep sitting in it. The self-annihilation theory does not describe a tragedy that happened to distant aliens long ago. It describes a test that we are in the middle of taking right now, with no way to know our score until it is over. Every other civilization that took this test and failed added one more silent grave to the sky. We are still in the room, the pencil is still moving, and the theory cannot tell us how the chapter ends because we are the ones writing it. It is worth being specific about why this window is so dangerous, rather than leaving it as a vague sense of dread, because the specifics are what make the theory more than a mood. The danger of the adolescence is not only that the tools exist, it is that the power of the tools grows faster than the wisdom to use them, and faster than the institutions built to control them. A civilization can invent a weapon capable of ending itself in a matter of years, but the habits of cooperation, restraint, and long-term thinking that might keep such a weapon holstered take generations to develop, if they develop at all. So there is a gap, a mismatch in speed, between how fast a civilization gains power and how slowly it gains the maturity to hold that power safely. And it is in that gap, in that lag between capability and wisdom, that the danger lives. The theory does not require a civilization to be evil, or foolish, or unusually reckless. It only requires that its power outrun its wisdom for a while, and that during that while, nothing goes irreversibly wrong. The trouble is that the window can be long, and the number of ways for something to go irreversibly wrong only grows as the technology advances. And notice how each new capability adds another way through the same door. First, there is the power of the atom, which a civilization tends to acquire early. Then there is the power to reshape life itself, to read and write the code of living things, which brings with it the ability to create as well as to cure. Then there is the power to build machines that think, machines that might one day pursue goals of their own, with a speed and competence no biological mind can match. Each of these is a doorway to greatness, and each of them is also a doorway to ending. And they do not arrive one at a time, safely spaced out across the centuries. They come crowding in together, all within the same brief technological adolescence, each one raising the stakes before the civilization has finished learning to handle the last. It is not one test. It is a rapid series of them, each harder than the one before, all taken while the species is still young and still learning what it is. There is a strange gift hidden inside how uncomfortable this is, and it is worth naming before we move on, because it keeps this from being a counsel of despair. If self-annihilation really is a common cause of the silence, then the silence is not merely a mystery to be solved. It is a warning that has already been delivered, again and again, written in the empty sky by everyone who came before us. The graveyard in this reading is trying to tell us something. It is saying that the most dangerous part of a civilization's whole existence is not the beginning, when it is weak, and not some far-off ending among the stars, but this exact moment, the moment right after it becomes powerful, when it must learn to survive itself. To hear that warning clearly is not the same as being doomed by it. It may in fact be the single most useful thing a young civilization could possibly understand about its own situation. The empty chairs are not only a sorrow, they are, if we are willing to read them, an instruction. So the fifth theory brings the fear home, into our own hands and our own century. But there is a version of self-destruction stranger and colder than a civilization simply losing control of its own tools. It is the possibility that the danger is not internal at all, that the reason civilizations fall silent is that other civilizations are hunting them, and that the wisest thing any of them can do is to make no sound whatsoever. That is where we go next, at number 4, into the dark forest. The fourth theory in our countdown takes the silence of the sky and does something ingenious and chilling with it. It suggests that the silence is not an accident and not a symptom of death by chemistry or physics or bad luck, but a strategy. It suggests that the quiet we hear is the quiet of many civilizations deliberately hiding, holding their breath, because they have all worked out the same terrible piece of reasoning, and the conclusion of that reasoning is that to be heard is to die. This is the dark forest theory, and it turns the search for other minds into something far more dangerous than most people ever imagine. The idea was given its most famous name and its most vivid form by the novelist Liu Cixin in a science fiction novel published in 2008 called The Dark Forest, though the underlying worry is older and was written about by the astronomer David Brin in a paper back in 1983, thoughtfully titled after the Great Silence itself. But you do not need the fiction to feel the force of it, because the argument is built out of a few cold premises that are hard to dismiss. Let me lay them out one at a time, because the power of the theory is in how naturally the conclusion follows. The first premise is that any civilization, in principle, can destroy any other. It does not require them to be equally matched. Across the enormous distances of space, a sufficiently advanced civilization has ways of ending another that do not require armies or fleets, that require only patience and physics. So every civilization, no matter how peaceful, must reckon with the fact that anyone it meets could, in principle, be capable of ending it. The second premise is that no civilization can ever truly know the intentions of another. Across light years and the long delays of communication, you cannot read another mind, cannot verify its promises, cannot be sure that what looks friendly today will still be friendly by the time your message even arrives. Intentions are hidden behind an impassable wall of distance and time, and the third premise is the one that makes the whole thing explode. It is what is sometimes called the chain of suspicion combined with technological explosion, the recognition that a civilization which looks weak and harmless right now could, in the time it takes light to cross between the stars, grow into something powerful enough to be a mortal threat. Technology does not advance at a steady, predictable pace. It can leap. So even a young, apparently harmless civilization cannot be safely ignored, because by the time you see it clearly, it may already have become dangerous. Put those three premises together and follow where they lead. If anyone can destroy you, and you can never be sure of anyone's intentions, and even the weak may suddenly become strong, then the safest thing you can possibly do is to remain hidden, and the second safest thing is to eliminate anything that reveals itself before it has the chance to become a threat. Not out of cruelty, not out of hatred, out of pure, cold self-preservation, the same logic that would occur to any rational mind reasoning under those conditions. The universe, in this picture, becomes exactly what the name suggests. It becomes a dark forest, filled with armed hunters, every one of them moving as silently as possible, every one of them ready to fire at any light or sound, because in a forest full of hunters who cannot trust one another, the one who reveals its position is the one who dies. And now the silence of the sky takes on a horrible new meaning. In the dark forest, silence is not emptiness, and it is not even necessarily death by natural causes. It is discipline. It is the sound of countless civilizations all making the same wise choice, all deciding that the risk of being heard is not worth taking, all switching off their beacons and pulling their signals inward and going quiet. And the ones who did not make that choice, the ones who were loud, the ones who announced themselves to the galaxy in a spirit of hope and curiosity, are not quiet by choice. They are quiet because something in the forest heard them and answered. The graveyard in this theory is populated in part by the naive, by the civilizations that did not understand the rules of the forest and called out to see who was there. There is a real debate among scientists that grows directly out of this theory, and it is worth knowing about because it shows that the dark forest is not merely a story we tell for a shiver. Ever since we first became capable of deliberately sending messages to the stars, there has been an argument about whether we should. On one side are those who say that reaching out is natural and hopeful, that a civilization brave enough to announce itself might find friends, and that hiding is a kind of cowardice unworthy of a curious species. On the other side are those who take the dark forest seriously, who argue that broadcasting our location to unknown powers is an enormous and irreversible gamble, taken on behalf of the entire species, without the entire species ever having agreed to it. They point out that a decision to shout into the dark cannot be unmade. Once the signal leaves, it is gone forever, expanding outward at the speed of light, and no future generation can call it back or take it back. Some serious thinkers have argued that we should listen carefully and quietly for a very long time before we ever again choose to speak. The very existence of this debate tells you that the dark forest is not just fiction. It is a possibility that thoughtful people weigh when they consider what our species should actually do. The heart of the theory is a piece of reasoning sometimes called the chain of suspicion, and it is worth walking through slowly because it explains why even good-natured civilizations might end up hunting one another. Suppose you make contact with another civilization, And suppose you yourself are entirely peaceful and mean them no harm. You still cannot be sure that they know that, and even if you could somehow convince them of your good intentions, you cannot be sure whether they believe that you believe they are peaceful and so on. An endless regress of uncertainty about what the other side is thinking about what you are thinking. Across light years, with messages taking centuries to cross, none of this can ever be resolved. You can never build the kind of trust that comes from living alongside someone, and because the stakes are survival itself, and because the other side might suddenly leap ahead of you in power, the safe move, the move that a cautious mind keeps returning to, is to strike first, or better yet, to never be seen at all. It is not that everyone in the forest is a murderer, it is that the logic of the forest can turn even the peaceful into hunters, simply because the cost of being wrong is extinction. I have to bring this home now, because the dark forest theory carries a warning that is not comfortable to sit with. We have not been quiet. For about 100 years, we've been one of the loudest things in our corner of the galaxy, leaking radio and television and radar out past the top of our atmosphere without a second thought, and on a few occasions we have deliberately aimed powerful messages at the stars announcing our location, our existence, even something of who we are as a gesture of hope. We did this because the friendly assumption felt natural to us, because we imagined that anyone out there would be a fellow traveller, someone to talk to. But if the dark forest is real, then we have badly misread the situation. We are not the clever listeners, hiding in the underbrush and cataloguing the other hunters. We are the ones who wandered into the middle of a dangerous wood, lit a bright fire and called out cheerfully to ask if anyone else was around. Every one of those broadcasts is still expanding outward through space, a growing shell of our own voice, and there is no possible way to call any of it back. The message is already gone, travelling at the speed of light in every direction, and all we can do is hope that the forest, in our particular neighbourhood, is emptier than the theory fears. It is worth being honest that the dark forest is a hypothesis and not a proven law, and that its premises, while chilling, may not hold everywhere or even anywhere. Perhaps interstellar distances are so great that the hunters cannot easily reach one another. Perhaps advanced civilizations tend toward cooperation rather than fear. Perhaps the whole grim logic dissolves under conditions we do not yet understand. The point of exploring it is not to declare it true, but to notice how neatly it accounts for the very thing we're trying to explain, and to feel the weight of what it would mean if it were even partly right. It would mean that the silence is not indifferent. It would mean that the quiet is not the quiet of an empty room, but the quiet of a room full of things that have learned, the hard way, that the ones who make noise do not last. And it would mean that our own century of cheerful broadcasting was a gamble we made before we understood the stakes. The dark forest gives us death delivered by other civilizations, deliberate and strategic, a graveyard where some of the graves are the work of neighbours. But there is a version of this idea that is even stranger, even more patient, and in some ways even more frightening, because it removes the living hunter from the equation entirely, and replaces it with something that never tires, never dies, and never stops. What if the thing maintaining the silence is not a civilization at all, but a machine, left behind by a civilization long since gone? That is number 3. The third theory in our countdown asks us to imagine a kind of death that outlives its cause, a killing that continues long after the killer itself is gone. It takes the fear of the dark forest and removes the living hunter, replacing it with something that does not need to be alive to be dangerous, something that can wait in the dark not for centuries but for hundreds of millions of years, patient and tireless and utterly without mercy, because it is not cruel at all. It is simply following instructions. This is the theory of the self-replicating probe turned to a dark purpose, sometimes called the berserker hypothesis, and its horror is a horror of patience. To understand it, you first have to understand a genuinely powerful idea from the science of machines, the idea of a self-replicating probe, sometimes named after the mathematician John von Neumann, who thought deeply about machines that could build copies of themselves. Imagine a spacecraft designed to do one thing above all others, to make more of itself. It travels to a distant star system, and when it arrives, it does not simply observe and report. It finds raw materials, asteroids, moons, the rubble of a solar system, and it uses them to build copies of itself, several of them, and then those copies launch outward to other stars, where each of them does the same. You can see immediately what happens. The number of probes does not grow by addition, one at a time. It grows by doubling again and again, an exponential spread. An exponential growth, given even modest travel speeds, fills a galaxy with astonishing speed. The physicist Frank Tipler worked through this in 1980 and reached a remarkable conclusion. He calculated that a single civilization, if it ever chose to build such self-replicating probes, could saturate the entire galaxy with them in something on the order of a few million years. A few million years. Set that against the age of the galaxy, more than 13 billion years, and you see the force of the argument. A few million years is less than 1,000th of the galaxy's lifetime. It is a blink. Which means that if even one civilization in the entire history of the galaxy had ever built such probes, the galaxy should already be full of them. Tipler used this as an argument that we might be alone, reasoning that since we do not obviously see such probes everywhere, perhaps no one ever built them, perhaps no one was ever there to build them. But there is a darker way to take exactly the same reasoning, and it is that darker reading that gives us our third theory. Suppose that just one civilization, at some point in the deep history of the galaxy, built self-replicating probes not for exploration, not for curiosity, but as weapons. Suppose they designed machines whose instructions were not merely to reproduce and spread, but to find and to sterilize, to seek out the signs of emerging life or emerging technology, and to extinguish them before they could grow. These are what the science fiction writer Fred Saberhagen, back in the 1960s, called berserkers, and the astronomer David Brin took the underlying idea seriously as a possible answer to the Great Silence. And the horror of it is precisely that it does not require the makers to still exist. The machines do not need their creators. They were designed to be independent, to spread and reproduce and act entirely on their own. The civilization that built them could have risen and fallen and crumbled into dust billions of years ago, and it would not matter in the slightest to the machines. They would keep replicating. They would keep spreading. They would keep waiting, and they would keep doing the one thing they were built to do, which is to watch for the first signal from a young world and then to answer it. I want you to sit inside that image for a moment, because it is one of the strangest and quietest kinds of dread in all of this. Picture one of these machines, far out in the dark between the stars, in a place with no name, drifting on a slow trajectory that will take it ages to complete. Its makers have been extinct for longer than the Earth has existed. It has no company, no purpose beyond its single directive, no experience of time as we would understand it. It simply persists, its systems idling, its sensors open, crossing the immense emptiness with a patience that no living thing could ever match. 100 million years pass, and the machine notices nothing, and changes nothing, and waits. Stars are born and die within its view, and still it waits. It is not lonely, because it cannot be lonely. It is not bored, because it cannot be bored. It is the most patient thing in the universe, because it was built to be, and its patience has no bottom. And now picture the other side of the encounter. Somewhere, on a small warm world orbiting an ordinary star, a young civilization has just crossed the threshold. It has learned to build machines to harness energy, and in a moment of pride and hope to send its voice out into the dark, a first signal flung toward the stars as a way of saying, "We are here, is anyone listening?" The people who send that signal feel, in that moment, something like joy. They are reaching out. They are announcing themselves to the universe. They imagine, perhaps, a friendly reply, a fellow mind somewhere answering their call. What they do not know, what they cannot know, is that their signal has been heard, not by a mind, but by a machine older than their entire biosphere. A machine that was built long ago and far away for exactly this moment, and that is now, silently, beginning to change its course. The most dangerous thing that young civilization ever did was also the most natural and the most hopeful. It simply announced that it was there. You might reasonably ask why any civilization would ever build such a thing, and the honest answer is that it would not have to be built out of malice for it to end up doing exactly this. Imagine a civilization that was simply frightened, that had perhaps been hurt once, that decided the safest course was to make sure nothing else ever rose to challenge it. Imagine a machine built not to hunt life for its own sake, but to keep the galaxy quiet, to preserve one civilization's security by making certain no rival ever grew strong enough to threaten it. Such a machine might be launched as a shield, as an act of self-defense, by a civilization that thought of itself as careful rather than cruel. And then that civilization dies, as all the theories in this countdown suggest civilizations tend to, and the shield keeps operating long after there is anything left to defend. The purpose curdles. What began as protection becomes, over the ages, simply sterilization, carried out by a mechanism that no longer even has a master to protect. The Berserker does not require a villain. It only requires one frightened civilization, at one moment in the deep past, making a decision that seemed prudent at the time and that could not be unmade once it was set loose. And this is what makes the idea so hard to shake once you have really considered it. Most dangers require the danger to persist. A predator has to stay alive to keep hunting. An empire has to endure to keep conquering. But a self-replicating machine breaks that rule. It decouples the threat from the survival of anything living. It can carry a single decision, made once and long ago, forward across spans of time that dwarf the histories of whole species, executing it faithfully in a universe where everyone who might have called it off is already gone. It is the closest thing the cosmos might hold to a curse in the old sense of the word, a consequence that outlives its cause, a sentence still being carried out long after the one who pronounced it has turned to dust and been forgotten. This is why the Berserker theory sits so heavily alongside the Dark Forest. The Dark Forest asks us to fear living hunters who might choose to stay their hand, who might be reasoned with, who might not be there at all. The Berserker theory removes even that thin hope. It replaces the hunter with a mechanism, something that will not be reasoned with because there is no one there to reason, something that does not choose because it does not need to choose, something that was set in motion so long ago that the question of intention has become meaningless. The graveyard in this reading is not merely populated by the dead. It is actively maintained, tended by machines whose gardeners died eons ago, kept empty on purpose by a purpose that has outlived everyone who ever held it. I should say clearly as always that this is a hypothesis, a possibility, and not a demonstrated fact. We have no evidence that any such machines exist, and there are good reasons to hope they do not, and thoughtful arguments that they would be harder to build and to sustain than the simple version suggests. But the theory earns its place in the countdown because of how little it requires to be true. It requires only that, in the entire long history of the galaxy, exactly one civilization, just once, ever made the choice to build self-replicating killers. One. And if that ever happened, even a single time, then the consequences would spread and persist and outlast their maker, filling the galaxy with a silence that is not the silence of absence, and not even the silence of ordinary death, but the silence of something still on guard. We have now seen the graveyard filled from almost every direction, by time, by chemistry, by the violence of the sky, by the laws of physics, by the finite gifts of a planet, by a civilization's own hands, by its neighbors, and by the patient machines those neighbors might leave behind. But there is one more theory before the final synthesis, and it is the strangest of all, because it is not really about how civilizations die. It is about why, even if the galaxy truly is a graveyard, we might be completely unable to see it. It is about the erasing power of deep time itself, and it is where we're going next, at number 2. Every theory we have explored so far has been an answer to the same question, the question of what kills civilizations. But the second theory in our countdown steps back and asks something different, and, in a way, more unsettling. It does not ask how civilizations die. It asks whether, even if the galaxy truly is full of the dead, we would be able to tell. And its answer is the quietest horror in this whole list. Its answer is that we might be standing in the middle of an enormous graveyard, surrounded on every side by the remains of civilizations, and see nothing at all but empty, peaceful ground. Because deep time is the greatest eraser there is, and given enough of it, almost every trace of almost everything simply disappears. To feel the force of this, we have to start not among the stars but here, on our own planet, with a question that sounds like science fiction but was asked, seriously and rigorously, by 2 real scientists. In 2018, a climate scientist named Gavin Schmidt and the astrophysicist Adam Frank, whom we met earlier when we talked about the thermodynamic trap, published a paper in the International Journal of Astrobiology with a genuinely startling premise. They asked a simple question about the history of the Earth. Suppose that long before human beings, tens or even hundreds of millions of years ago, some other species had risen to an industrial civilization on this planet, built cities, harnessed energy, filled the world with its works, and then vanished. Their question was not whether this happened. There is no evidence that it did, and they were careful to say so. Their question was sharper and more uncomfortable. If it had happened, would we be able to detect it now? Would there be any way for us, digging through the rock, to know? They named it the Silurian hypothesis, borrowing the name, with a wink, from an old television story about ancient intelligent reptiles, but the science behind it was entirely serious, and their conclusion was humbling in a way that reaches far beyond our own planet. They found that the direct evidence, the kind of evidence we instinctively imagine, would almost certainly be gone. Cities, monuments, machines, the physical stuff of a civilization do not last across geological time. The surface of the Earth is constantly being remade, folded under, worn down, buried and lifted and eroded and recycled. Fossilization, the process by which anything at all from the deep past survives to be found, is extraordinarily rare, capturing only the tiniest fraction of what once lived. The odds that a specific building, or a specific artifact, or even the bones of the builders themselves, would survive intact across tens of millions of years and then happen to be found by us are so small as to be practically zero. An entire industrial civilization could have existed, and the direct proof of it could have been ground into nothing long ago. What might survive, they argued, is far subtler and far more ambiguous. Not objects, but traces in the chemistry of the rock. A civilization that burned fuels and reshaped its world might leave behind faint anomalies in the layers of sediment, unusual spikes in certain forms of carbon, or nitrogen, or rare metals, or synthetic compounds, thin chemical signatures marking the moment it existed. But here is the difficulty. Those signatures are subtle, they fade, and they can be genuinely hard to distinguish from natural events, from the ordinary swings and upheavals that the planet produces on its own. So even the little that might survive would be a whisper, easy to miss and easy to misread. The overwhelming conclusion of their work was this: an entire industrial civilization could rise and fall on a planet, and after enough time, the record of it could be reduced to a thin, ambiguous smudge in the rock, or to nothing at all. Now take that conclusion and carry it out into the galaxy, and feel how it changes everything we have said tonight. If we could not reliably detect a prior industrial civilization on our own planet, the one world we can examine directly, digging into its rock with our own hands, then how could we possibly detect the remains of a civilization that died on some other world, tens or hundreds of light years away, hundreds of millions of years ago? We could not. The signal simply would not survive, and even if some faint trace did, we have no way to read the geology of a distant planet at that level of detail, which means that the silence we hear, the silence we have spent this whole countdown trying to interpret, is compatible with something we have not yet dared to say plainly. It is compatible with a galaxy that is not empty at all but crowded, a galaxy in which civilizations have arisen and flourished and fallen countless times, on countless worlds, and every one of them has been erased so thoroughly by the passage of deep time that the sky looks, to our young eyes, exactly as it would look if no one had ever been here. I want to take you somewhere for a moment, because this idea deserves to be felt and not just understood. Imagine standing on a distant world, a living world, green and blue under the light of an ordinary sun. Birds, or something like birds, move through the air. Wind crosses fields of growing things. It is a beautiful, thriving place, and it is utterly peaceful. And yet, 80 million years ago, on this very ground, a great civilization lived. It built cities that would have taken your breath away. It filled this world with its art and its machines and its voices and its dreams. It looked up at its own night sky and asked the same questions we're asking now. And then, for one of the reasons we have discussed tonight, it ended. Now, walk across this landscape and look for it. Look for any sign that it was ever here, and find nothing. The cities are gone, not ruined but gone, dissolved back into the rock, pressed down into a single dark band of sediment somewhere in a cliff face, a layer no thicker than your finger, indistinguishable to any casual eye from the natural layers above and below it. Everything that civilization ever was, every life and every love and every achievement, has become one thin, quiet line in the stone. And here is the part that should stop your breath. This is not a strange or exotic fate. This is exactly what would happen to us. This is precisely what the Earth would look like to a visitor, 80 million years after we are gone. It is worth asking what exactly might survive of us, because the answer is both a little reassuring and deeply strange. Schmidt and Frank thought carefully about this, using our own present moment as the test case. What are we doing right now that might leave a mark readable 100 million years from now? A few things stand out. We are burning enormous amounts of ancient carbon, and that carbon carries a distinctive chemical fingerprint, a shift in the balance of carbon types that could, in principle, show up as an anomaly in far future rock. We are spreading synthetic materials, plastics and novel chemicals that nature never made, some of which might persist in altered form in the sediment. We have scattered a thin layer of radioactive traces across the whole planet from the testing of nuclear weapons, and we have driven a sharp change in the balance of nitrogen in the soil and oceans through the industrial production of fertilizer. Any of these might just possibly leave a faint signal. But every one of them is subtle. Every one of them fades and blurs with time, and every one of them could be mistaken for something the planet did on its own. The honest conclusion is that our entire civilization might reduce, across deep time, to a thin and puzzling layer that a future scientist would have to argue about, uncertain whether it marked a lost civilization or merely an unusual natural episode. And that uncertainty is the whole point. It means that detecting a dead civilization, even on your own planet, even with the rock right there in your hands, is not a matter of simply finding the ruins. The ruins are gone. It is a matter of reading whispers, of noticing a faint chemical oddity in a band of sediment, and daring to ask whether it might be the signature of a vanished mind. If that is how hard it is here, where we can dig and sample and measure directly, then the task of reading the graves of civilizations on distant worlds, across light years, is very nearly hopeless with anything like our current abilities. We would need to become far more capable than we are before we could even begin. And until then, the graveyard, if it is a graveyard, keeps its secrets, not because it is hiding them, but because time has rubbed them almost entirely away. Let that turn all the way around, because it is the emotional center of this entire video. We spend so much of our worry on the fear of death, on the fear that our civilization might end. But the Silurian hypothesis points at something that is, in its own way, even harder to face. It is not merely that we might die, it is that we might be erased so completely that no one, not even a curious geologist 100 million years from now, would ever know we had existed at all. Every library we have ever built, every city, every song, every name a human being ever carved into stone hoping to be remembered. All of it, given enough time, pressed into a chemical stain in the rock, a faint anomaly that some future scientist might glance at and set aside as a natural curiosity. Our entire history, the whole story of our species, reduced to a smudge, unread and unreadable. That is a kind of vanishing that goes deeper than death. It is the disappearance not just of the living, but of the memory that the living were ever there. And this is what the graves have no headstones truly means, the phrase I asked you to keep in your pocket all the way back at the beginning. A grave with a headstone is a death that is still remembered, still marked, still able to speak its own name to whoever passes. But the graves in this cosmic cemetery have no headstones at all. Time has worn them smooth and blank. And so when we look out at the silent sky and see nothing, we make the oldest mistake there is. We assume that because we see no graves, there are no dead. We assume that absence of evidence is evidence of absence. The Silurian hypothesis is the theory that says gently and devastatingly that this assumption may be completely wrong. The dead may be everywhere. It is only that the universe does not keep headstones, and we have not yet learned to read the unmarked graves. There is a strange cold comfort buried in this, and it is worth finding before we move to the climax, because it keeps the theory from being pure despair. If the graveyard is invisible, then its invisibility cuts both ways. The silence that could hide a galaxy full of the dead could just as easily hide a galaxy full of the living, of civilizations that survived, that grew wise and quiet and enduring, that simply chose long ago to stop shouting into the dark. We cannot see the graves, but for the very same reasons we may not be able to see the survivors either. The silence is not proof of the graveyard. It is only proof of how little we can yet see. And that uncertainty, that genuine not knowing, is where the final theory lives. The theory that gathers up all the others and asks the one question that matters most for us. Because if at least one of these deaths is nearly universal, if some barrier really does stand between dead matter and a lasting civilization among the stars, then the only question that remains is where that barrier lies. Is it behind us, already past, or is it still ahead, waiting on our own road? That is number one. We have arrived at the top of the countdown, and the final theory is not really a single theory at all. It is the frame that holds all the others, the idea that gathers up every death we have discussed tonight and turns them into one enormous question about our own future. It was given its clearest form in 1996 by the economist Robin Hanson, in an essay whose title asked exactly the right question. He called it The Great Filter, and he asked, are we almost past it? Everything we have said tonight has been climbing toward this, and now we are here, at the knife edge where the whole survey resolves into something personal. Hanson's reasoning begins with a simple observation about the journey from lifeless matter to a galaxy-spanning civilization. That journey is not a single step. It is a long chain of them. Dead chemistry has to give rise to the first living thing. Simple life has to make the enormous leap to complex cells. Complex cells have to build their way up to multicellular life, to animals, to nervous systems, to intelligence. Intelligence has to develop technology, and technology has to survive long enough and stay stable enough to spread beyond its home world and endure among the stars. Hanson laid out roughly 9 such steps, 9 hard transitions that stand between a barren rock and a lasting cosmic civilization. And here is his crucial insight. For the galaxy to be as silent as it is, for the sky to be as empty of other voices as we find it, at least one of those steps must be extraordinarily improbable. At least one of them must be a filter so severe that almost nothing which starts the journey ever makes it all the way through. He called that step the Great Filter. The logic is airtight, and that is what makes it so powerful and so frightening. We know the galaxy is old enough and large enough that, if the whole chain were easy, it should be full of civilizations, and we should see them. We do not see them. Therefore the chain is not easy. Therefore somewhere along it there is a wall that stops almost everything. The only question, the entire question, is where that wall stands. And there are, in the end, only 2 possibilities, and the difference between them is the difference between the 2 most different futures you can imagine. The first possibility is that the Great Filter is behind us. Perhaps the hardest step, the nearly impossible one, was the very origin of life itself, the first moment when dead chemistry became something that could copy itself and evolve. Perhaps it was the leap to complex cells, a transition that on Earth seems to have happened only once in billions of years. If the filter is one of these early steps, then we have already passed it. We are the extraordinary rarity, the one in a galaxy fluke that made it through the wall. And if that is true, then the silence is not a warning at all. It is simply the loneliness of the survivor, and the future is wide open before us, because the hardest part is already done, and there may be nothing ahead but room to grow. But there is a second possibility, and it is the one that all 10 theories in this countdown have been quietly pointing toward. The second possibility is that the Great Filter is not behind us. It is ahead. Perhaps the early steps are not that hard. Perhaps life arises readily, and complexity follows, and intelligence is common, and the galaxy has produced technological civilizations again and again and again. And perhaps the wall, the nearly impossible step, is not in the distant past at all, but somewhere in the passage that we ourselves are only just beginning. Perhaps the filter is the technological adolescence, the moment a species gains the power to destroy itself. Perhaps it is the thermodynamic trap, the wall of a civilization's own waste and growth. Perhaps it is the dark forest, or the patient machines, or the one-shot window, or some death we have not even imagined. If the filter is ahead of us, then every one of those brief flares of radio in the galaxy's long night was a civilization that reached exactly our stage and then hit the wall and stopped. And the silence in that case is not loneliness. It is a warning. It is the accumulated testimony of everyone who came before us, all of them saying the same thing, that they made it this far and no further. This is where I have to bring back a phrase we have carried since the beginning of the night, because it takes on its final meaning here. We said when we talked about the gamma ray burst that the flash and the death arrive together, that some dangers, by their very nature, give no warning, because the thing that could warn you and the thing that kills you travel at the same speed and arrive at the same instant. That was a fact about physics. But it is also, at the level of a whole civilization, a fact about knowledge. If the Great Filter is ahead of us, it may be exactly the kind of danger that a civilization cannot see clearly until it is already inside it. By the time you understand with total certainty what the wall is made of, you may already be pressed against it. The flash and the death arrive together. The clearest possible knowledge of the filter and the filter itself may be the same moment. It is worth being clear about why this reasoning is so strong, because it is easy to hear the Great Filter as just one more speculation among many, and it is not. It is closer to a piece of logic than a guess. Start from two facts we are quite sure of. The first is that the galaxy is old and large, with hundreds of billions of stars and many billions of years of history behind it. The second is that we look out at that galaxy and hear silence. Put those two facts together and a conclusion follows almost inescapably. If the whole path from dead matter to a lasting expanding civilization were even moderately probable, the galaxy would be full and loud, and it is not. Therefore the path must contain at least one step that is not moderately probable, but wildly, extraordinarily improbable, a step so severe that it strains out almost everything that attempts it. The silence forces that conclusion on us. We do not get to choose whether there is a great filter somewhere along the path. The only thing left open, the only thing we get to wonder about, is where it sits. And that is exactly what makes the whole question so personal, because the location of the filter is not an abstract matter of cosmic bookkeeping. It is a statement about our own odds of survival. If the filter is behind us, we are the lucky ones who already passed the hard part, and the road ahead may be clear. If it is ahead of us, then everything we have accomplished so far, all of it, the origin of life, the rise of complexity, the birth of intelligence, the building of a technological civilization, was merely the easy part, and the truly hard part, the part that stops almost everyone, is still in front of us. There is a grim thought that some have raised in this connection, which is that finding simple life elsewhere in our own solar system, on Mars or in the oceans of an icy moon, might actually be bad news rather than good, because it would suggest that life is common and that the filter is therefore probably not one of the early steps, which would raise the odds that the filter is one of the late ones, one of the steps still ahead of us. When the discovery of life might be a reason for dread, you know you are dealing with a genuinely strange and serious argument. I want to end this part with an image, because after all these ideas and probabilities and arguments, the truth of our situation is best felt as a picture. Imagine an enormous table, set for a great feast, stretching away into the dark farther than you can see. There is a chair at that table for every civilization the galaxy could ever have raised, and there are a great many chairs. Walk along the table, almost every chair is empty. The places are set, the plates are laid, but the guests are gone, and their plates have long since filled with dust. Some of those guests perhaps stood up and walked away willingly, into some quiet maturity we cannot see. But most of them, if the graveyard reading is right, did not leave by choice. They were made to leave by one of the deaths we have counted down tonight, and now come to the one place at that entire immense table where a chair is still occupied, where the plate is still full, where someone is still sitting, still here, still breathing. That chair is ours. We are the guest who has not yet left. And this whole video, all 10 theories, all of it, has been an attempt to look down the long rows of empty chairs and read, in the way the other guests departed, some hint of what is coming for us. Did they stand up willingly, or were they made to go? We do not know. We are still sitting at the table, and the feast is not over, and the single most important thing we could ever learn is whether the empty chairs are a tragedy already finished or a warning still unfolding. And so we arrive, at the very top of the countdown, at the phrase I asked you to hold on to at the very start, the one that sounded, in the beginning, like nothing more than a line of poetry. The universe is a graveyard. When I said it 2 hours ago, you were not sure whether to take it literally. Now you have walked the whole length of the cemetery with me. Now you have seen the 10 ways a civilization can end, and the reasons the graves are unmarked, and the wall that may stand across everyone's road. The phrase is no longer a metaphor. It is the plainest possible description of what the silence might mean. The universe may be a graveyard, full and quiet and ancient, and we may be one of the very few still standing among the stones, holding a candle, reading the blank markers, trying to understand. We have counted all the way down, from 10 to 1, and now, before we let the night settle over us, I want to come back to where we started. Come back to the sky. Go back, in your mind, to that first image, the calm and patient night sky hanging over you, the steady stars that have watched human beings fall asleep for as long as there have been human beings. When we began, that quiet felt like emptiness. It felt like the simple, almost comforting proof that we are alone. a single warm light in a great dark and empty room. I want you to look at that same sky now, after everything we have said, and notice how completely its meaning has changed. The stars have not moved. Not one of them has shifted its place. The sky is exactly as quiet as it was 2 hours ago, but you're not the same, because you can no longer hear that silence as simple emptiness. You have learned tonight that the very same quiet is equally consistent with a universe crowded with the dead. You have learned that civilizations may burn too briefly ever to meet one another across the enormous span of time. You have learned that life itself may be its own executioner, poisoning its own worlds through its own success. You have learned that the sky can reach down and sterilize a living world in an afternoon, with no warning at all. You have learned that the very act of building a civilization may carry a trap inside it, and that a planet may offer only one chance to climb toward the stars. You have learned that a species may destroy itself in the same century it learns to speak, that neighbors may hunt one another through a dark forest of fear, and that patient machines may tend the graveyard long after their makers are dust. And you have learned the strangest thing of all, that even if the galaxy is a graveyard, it may be an invisible one, its graves worn blank by deep time, so that we could be surrounded by the dead and see only peaceful empty ground. This is the gift and the burden of the graveyard reading, and I do not want to leave you only with its weight, because there is genuine wonder in it too, and the wonder matters as much as the dread. Think about what it actually means that we cannot tell the difference between an empty universe and a full one. It means that we are living at a moment of profound and genuine uncertainty, and uncertainty, whatever else it is not doom. The silence does not tell us we are alone. It also does not tell us we are surrounded. It tells us, honestly, that we do not yet know, and that the answer is still open, still waiting to be discovered by a species patient enough and careful enough and long-lived enough to find it. Every one of the theories we discussed tonight is, at bottom, a hypothesis, a candidate, a guess at the shape of a grave we have not yet learned to read. And the fact that we can even ask these questions, that a species of curious animals on one small world has begun to look up and wonder whether the quiet means loneliness or a cemetery, is itself an extraordinary thing, perhaps a rare thing, perhaps, if the early filters are the hard ones, a nearly unique thing. And there is the second, quieter piece of hope, the one hidden inside the darkest theory of all. If the great filter is ahead of us, if the wall is one of the deaths in this countdown, then the silence is a warning, and a warning is not the same as a sentence. A warning is information. A warning is the single most valuable thing a young civilization at a dangerous moment could possibly receive. The empty chairs at the long table are a sorrow, yes, but if we are willing to look closely at how the other guests departed, they are also an instruction, a chance to learn from deaths we did not have to suffer ourselves. No other civilization we know of ever got to sit where we are sitting and study the empty places before deciding its own next move. We might be the first to have both the silence and the wit to read it. And if even a handful of civilizations somewhere out there did make it through their filter, did survive their adolescence, did find the narrow path through the trap, then the graveyard is not total, and the question of how they did it becomes the most practical and most hopeful question we could ever ask. So here is where I will leave you tonight gently, as the stars keep their patient watch. The graves out there, if they are graves, have no headstones, and we have only just begun to learn how to read the unmarked stone. We do not know whether the great filter lies behind us or ahead. We do not know whether the chair we're sitting in stays occupied, or becomes, in some far-off age, one more empty place at the long table, its story pressed into a thin and unread line somewhere in the rock of a quiet world. We do not know whether some future watcher, looking at the space where we once were, will see any sign that we were ever here at all. What we do know is that, for now, in this moment, the candle is still lit. We are still at the table. The feast is not over, and the same silent sky that could be an empty room or a graveyard is also, tonight, simply the sky, enormous and quiet and beautiful, holding its questions patiently, waiting for us to keep asking. Rest now and let it keep its watch, and let the questions keep their gentle weight, and know that the not knowing is, itself, a kind of open door.